Swayam Prabha. Digital India. Educated India.
Welcome back. In lecture 32, we will talk about site selection for sanitary landfills. The different concepts that we will cover are the landfill site selection process, location criteria, search area, field visit and potential sites, ranking and selection of site as per CPCP guidelines. Then we will do a case study of calculation of site sensitivity index of two sites in Varanasi. Then final site selection and case study, and then we will do another case study on ranking and selection of sites from international case study, and finally we will look into data collection and site investigation that is required for selection, for gathering the data that is required for the site selection process. So the landfill site selection process, as in the last lecture we have discussed certain criteria for that as specified in the Solid Waste Management Rules 2016, but at the end of the day it is as per state policy and the Solid Waste Management Strategy and the Municipal Solid Waste Management Plan of the ULB which is taken into consideration. That means every state has its own set of rules and strategies that they formulate following the MSW rules, of course, but at the same time every ULB have their own specific plan, so the final landfill site selection is done according to that. And sometimes local landfills are not possible, that means there is not adequate space for creation of a local landfill site. So in that case a regional facility is required and a regional landfill is decided for adjacent ULBs of a particular area. Depending on the location of the landfill and the types of solid waste to be disposed, the environmental impact will also vary. So that means the environmental impact for each site is different, and what kind of environmental impact should be investigated in detail depends on what sort of waste is coming to the landfill as well as in which area we are present. So if it's a rainy area, we will go for certain kinds of parameters that we should check. If it's a dry area, we will look for other parameters maybe. So that determines in how the analysis should be done. Now, fundamentally, there are few things that we have to follow. One is the legal aspects. What are the laws? What are the rules of the land? So, of course, we have to follow the state policy and strategy and the MSWM plan and the MSW rules. So, these are the legal aspects that we have to follow. The environmental and health impacts, we have to understand what would be the environmental and health impact of a particular, of a choice to develop a landfill at a particular site. Socio-political issues, maybe we will find a site very suitable in every measure, but people in that area may not be accepting it. So, public acceptance is a key. So, that again becomes, we have discussed this earlier, right? So, this kind of protest can actually stop a project halfway after construction. It may get stopped with waste of time, money and all. And finally, the economic and the engineering cost. Now, a basic cost is obviously there. That means whenever we have to create an engineered facility, a sanitary landfill, there would be obvious engineering cost. But depending on which site we choose, this cost will vary. Because what happens, in each site, the impact is different. Now, if it is within the limits, that means then I have to say that, okay, in both cases there are some impacts, but it is within the limits that is allowed by as per rules. So, now how should I compare which one we should select, which site we should select? The one where the impact is less. Or how we can make the impact less? We can make the impact less by investment in liners, or better quality covers and so on. So, that means every site we can improve it by investing some amount of money in the different kinds of equipment or technologies that we use to design that particular site. So, in that case, this cost will also change for each site, right? So, engineering and economic cost plays a big role in selection of a particular site. So, and it's not only the cost of the actual construction, but also cost of mitigation of the environmental impacts and all, right? So all this overall needs to be considered. So what are the cost? So there are two parts to it. One is the development cost, that is the cost during the development phase of the landfill, and the long-term cost for the landfill as well. So it includes cost of land, construction cost of the landfill, transportation cost, that means how far away is the landfill is. If it is far away, every day I will spend money to transport waste over there. As we have discussed, this is the most costliest part of solid waste management. Access cost, that is within the site also access, or maybe the site is far away from the highway, so that we have to construct a road for that. Special equipment or facilities as per that particular site. Loss of alternative productive land use. Now, one landfill could be constructed at a barren site, whereas another landfill could be constructed in an agricultural land, and maybe it's a 3-crop agricultural land. So obviously, even though the land price may be not that different, but in future productive use of the land, that means we are not getting to create grow crops in this particular land for the 3 crops every year for the for the next 15, 20, 30 years. So in that case, it's a loss as well. So that also needs to be considered, and impacts on adjacent land use. Because if we construct a landfill, automatically the surrounding landfills will be impacted. Some maybe because of the environmental pollution, but primarily the overall cost of land in that area goes down. Overall, because of litter, because of odor, the overall quality of life in that area goes down, and that impacts everything. Nobody would like to come over there and so on. So that really brings the overall cost of land and the quality of life in that area. So all this should be considered under cost. Long-term cost is post-closure maintenance and leachate treatment. So this is for after the operation is over, we have to keep on monitoring the landfill. Post-closure operations are there, so that will also involve certain costs. So all this cost has to be considered when I choose a particular site. Now CPHEO has given us some stages in which we can go ahead with the site selection process. Again, this is not mandatory, but this is a process which is suggested by CPHEO. Obviously, other agencies or other bodies will suggest other ways also. But more or less, the basic process is same for everybody, right? So first of all, we have to decide on the location criteria. That means which are the aspects that will decide on the choice of a landfill site as per rules, as per environmental impacts and so on. Then search area. Now, in which area, suppose I have got a ULB over here. So, till what distance I will search for a landfill site, or because the ULB has its jurisdiction only over till this. So, should I search a landfill area within this area itself, right? So, all these things plays a role. So, search area is determined based on jurisdiction, legal, administrative, as well as consideration of the surrounding habitations and so on. Then development of a list of potential sites. So this is the first stage selection criteria. That means we can, based on land availability, based on government land availability, based on cost of land, we can create and based on the initial location criteria and search area, we can create a list of potential sites. Now we have to determine within this particular list of sites, or this maybe 10, 15 areas that we have found out, we have to find out which ones is the most suitable. And for that, we have to do a ranking procedure for these sites. And here again, we use several criteria to generate the ranks. Now, because we are using several criteria to generate the ranks, we require data. So that's why data collection is required, and field visit for local verification, because some data we can get from maps, secondary sources and so on, but a field verification is required for verification of those particular maps and all. If the current situation is same as what is depicted in the map, we can do some investigations locally, like groundwater level and all, soil type, all this we can do some test over there. And finally, this helps in identification of the potential sites. So once we create these ranks and all, then we can say that out of 15 sites, we take the top 3 sites, or maybe out of top 10 sites, I take the top 3 sites based on this ranking. then I do further detailed analysis which would probably look into the environmental impact of this particular 3 sites. Now, environmental impact analysis we have learnt earlier. So, over there we do detailed analysis of impact on air, impact on water, impact on all the other the surrounding habitat and so on. So, this requires lots and lots of detailed data and all. So, it's difficult to do this exercise for all the 10 sites. So, we can use a preliminary ranking procedure for this sites to reach at a consensus that these are the top 3 or 4 sites, and then we can do a detailed study of the environmental impact of this particular site. And the final site selection procedure not only considers environmental impact but other factors like cost, the distances, which are very pertinent in terms of the amount of money that we will invest in this particular area. So, this is the procedure selected as proposed by CPHEO, but obviously you can see that I can reduce all this into only one stage as well. That means I go and collect data from all the potential sites. I can do a detailed evaluation using this ranking method and say whichever is number 1, we will select that. But in that case, the ranking has to be very, very detailed, or the criteria that is utilized will include the cost of land, the transportation cost, land availability, environmental impacts, different kinds, everything has to be considered in the ranking procedure. So, if I don't want to do it in multiple stages, we can do it in one stage as well. But in that case, the amount of effort that we have to put is quite large because we have to collect detailed data from all these sites. Otherwise, we can do a initial ranking based on some criteria, and then we can do a detailed environmental impact analysis, assessment analysis on a few sites, and then finally, based on environmental impact and maybe some other parameters, we can do a final selection of the site. So, talking about location criteria, what are the aspects that should be covered? Now, the first thing that I will talk about is called a fatal flaw. Now, what's a fatal flaw? A fatal flaw removes a site from any consideration, no matter how favorable the site may be from other perspectives. That means the site may be absolutely good in terms of transportation cost, cost of land and all, but maybe one factor is such that it cannot be allowed to be a landfill site. And usually these factors are related with geology and slope, groundwater, surface water, land use and floodplain. So, if the site is within a 100-year floodplain, obviously we cannot have it because there is a chance of flooding. If it is in over a fault area or a subsidence area or near a geologic feature which compromises the structural integrity of that site, we cannot have it there. Groundwater, if we have the adequate depth, the groundwater table is available very near to the surface, in that case we cannot have it. Whatever you do, like hydraulic control, like we use pumps to lower the groundwater table, that means we create that cone of depression and we lower the groundwater table. So, in that case also, we can go for sites with a higher groundwater table, but still there is a basic limit of 2 meters as we have discussed in the previous lecture. No closer than 1000 feet to a down gradient drinking water well. So, this is one where different cities may have their own set of rules. Like, and then surface water, land use in the surrounding area, all this are considered. So, some of this may become a fatal flaw which will avoid us to have a landfill site over there. For every site which doesn't have a fatal flaw, we can do some other comparisons or do some ranking and other use criteria to determine its rank or weight or we can give it a score, and using that we can deselect a set of sites which are potential suitable sites. Now, here I have listed as per SWM 2016 and CPHEO, these are some of the factors which you can consider as an absolute must, or you can say even a fatal flaw while selection of landfill site. What are these? Like, sanitary landfill site is not permitted within coastal regulatory zones, wetlands, critical habitats, 100-year floodplains, eco-fragile areas and so on. It should be 100 meters away from rivers, 200 meters away from freshwater bodies, 30 meters away from non-meandering water channel, highway or 500 meters away from a highway minimum or a railway line, 500 meters away from settlements, human habitations, 500 meter from fault line fractures, right? Then sanitary landfill is not permitted in flat road. So these are the above 2 meter from a water table. Airport 20 kilometer, but 10 to 20 kilometer, as we have discussed, in certain special permissions can be obtained, then the site could be within 10 to 20 kilometers. So as per MSW rules, solid waste management rules 2016 and some other criteria, CPHEO has given, CPHEWO, they have given this set of criteria which could be utilized for pre-selection of sites that we should consider. So that means if any of this is violated, we have to immediately, let that site out of our contention. So then comes the search area. To determine search area, first we should understand how much area is required. So for that, CPHEO gives a table where gives certain specifications. For example, if the total quantity of waste which is measured in million tons per design life of landfill, that is total quantity of waste that will come to this landfill site. If it is less than 1 million, the total site area is 15 to 20 hectares. Similarly, if it is more than 3 million tons, then it is more than 40 hectares. So first criteria is this. That means if I know that this value we will know because I know per capita waste generation and other waste generation, and we can project that for a 25-year period, the total waste that is generated. Based on that, we can have a rough estimate of what kind of area is required. So this is that rough estimate which is given over here. Now, using this rough estimate, we can do pre-selection of sites. That means at least this much area has to be available over there. If the area is like 10 hectares, then obviously there is no point of considering it as a landfill site. So all this has to be considered. So ideally, the town planning department, or in case the town planning department is not there, that particular ULB identifies the potential site. So if it is available within the municipal boundary, fine, if there is adequate land there, but if not, then a regional facility may be considered. And they can do this initial selection based on a search radius, which is why, because then it will be within a transportation cost will be within a certain limit. So usually the search radius is like, for example, I have a ULB. Usually we take it from the center and we find the distance of the potential landfill site. So from this calculation, I can easily make out that what sort of cost will be there, and we have to do it for every day for so much quantity of so many lorries or so many vehicles and so on. So from that I can make an estimate and I can say that okay, I should not go beyond 15 kilometers or beyond 20 kilometers, something like that. So that then land ownership and cost. Who owns the land? Does government have land over there, or we have to buy that land? In that case, what is the cost of land? And then special design measures could be also adopted. Like for example, if there is no land available, sometimes we have to use the old dump sites or abandoned quarries and other kinds of areas, degraded areas in that particular locality. And then there has to be some special measures or special investment or engineering design that has to go to use this kind of sites as a landfill site. So absolutely, if there is no land available, then we have to, this is the second set of options that we have to consider. So once this search area is determined, then potential landfill sites are determined using further screening using more detailed criteria, and that is where the ranking and all this thing comes in. Now there are two ways to do that. We can either do it through the overlay mapping method. Overlay mapping method is, I have a map for slope, I have a map for soil type. So slope wise I say this area is suitable, then based on soil type I will see this area is suitable, the other soil type is not suitable, then we can have further criteria. In that way we can find that only a certain portion is suitable for setting up a site. So we can use this overlay mapping method and or multi-criteria evaluation or multi-criteria decision making. So I will show you examples of that, and that means we use several criteria and we give some weightage to each of these criteria, and we will measure the value of this particular aspect for each of this landfill site, and then we can arrive at overall score using all these criteria. That's why it's called a multi-criteria analysis. and we can select which site is better, right? So before we start this detailed analysis or ranking procedure, we have to go for field visit and we have to determine we have to do some basic evaluation, right? For example, we do site reconnaissance survey, we ground truth and confirmation of the maps from that we have obtained from secondary sources, topography, transport network connectivity, flooding, land use, soil types, subground data, what kind of underground this base we have got, like for example what kind of rocks are available below and all this, which may decide on what sort of measures we have to take. Then depth of groundwater table, high tension electrical line within the site, surrounding settlement patterns. So all this basic data has to be collected even before we go for detailed data collection. And again, as I told you that here we are talking about a much larger number of sites, right? So we cannot do very detailed investigation or detailed data collection for each of these sites, but at least some amount, like we have to do this basic investigation, we have to go to those sites, at least we have to do this kind of investigation or this kind of data collection. Now, Central Pollution Control Board along with NERI, National Environmental Engineering Research Institute, has given a guidelines for selection of site for landfill. Now, what they have proposed is, they have also proposed a ranking procedure where they have asked us to, where they have given a method to create a total or compute a total score based on weight of different criteria that are used for selection, multiplied by a site sensitivity index, right? So, sensitivity index, that means the value of that particular criteria for that particular site. Now, this overall, this is known as the site sensitivity index for landfill sites. Now, usually the weightage are determined via pair-wise comparison between the different criteria. That means we can ask experts for their opinions on, if I have got two criteria, that is, one is order from the landfill site and we have got leachate production. Which one is higher in the priority list? Which one is more harmful to the environment? They may say leachate is more harmful. So obviously leachate is more important than order. Similarly, there are other criteria as well. We can do pair-wise comparison, and using the pair-wise comparison, there are certain techniques called the analytical hierarchy process. Using that, we can determine the weight of each of these criteria. There are other methods also, like we can also use other techniques, like we ask people about what is the importance they think, and from there we also can compute the weights and all. But usually this pair-wise comparison is more robust. But in case there are lots and lots of criteria, then the pair-wise comparison is difficult to create, and we will go with importance rating and so on. So then we can use the Delphi technique, that we multiply the weights of importance of each of these criteria multiplied by the actual value of that criteria. This actual value is the sensitivity index for that particular criteria. So it's a relative measure. So there are 4 levels are created: 0 to 0.25, 0.25 to 0.5, 0.5 to 0.75, and 7.75 to 1. So this is a relative value. It's an index sort of thing that we are creating. That means for each criteria there is a weight, and then there is the value of that particular condition. For example, soil type. So order, leachate, soil type, maybe the weight of the soil type is 5, whereas order is 2, leachate is 6. These are the weights. And soil type now over here is clay soil. So clay soil, I will give a figure, or there is maybe sandy soil. Sandy soil probably gets a value which is pretty low, that is 0.75, whereas clay soil, which is good, it may get values such as 0.25, right? So 0 is given no or very less potential hazard, and 1 is the highest potential hazard. So that means if there is sandy soil, there is more chance of leachate going down. So that's why I have given a score of 0.75. Whereas in clay soil, there is less chance of leachate percolating. So I have given a value of 0.2. So we multiply weights with the actual value of soil for that particular site. Maybe there is clay soil. So we will multiply 5 into 0.25 and we get a score. And when we add up all these scores for all the criteria, we we are now doing a multi-criteria analysis, we get an overall score, and using that score, I can compare between different sites. But as you understand, these are relative criteria measures to determine what is the impact of this particular site. Now, environmental impact assessment, there we have to actually find out the detailed measures of how harmful that particular site is to the surrounding environment by either by monitoring the particular location in regards to quality of water or air, or by doing some sort of calculations to project what will be the impact for that particular area. So all this requires certain attributes to be selected. So in this case of this guidelines, CPCB have considered 32 attributes, and these are over 7 categories. That means they have sub-categorizes them into 7 categories, and then in each category there are several attributes, and overall there are 32 attributes. Now, there is one benefit of doing this categorization. When you do pairwise comparison, this categorization helps you to reduce the total number of pairwise comparisons that you can do. So you do pairwise comparisons between the categories, between the this attributes which are within the category, and then between the categories we can do another layer of this comparison. So attribute selection is based on literature, expert views, and the pollution pathways. That means what impacts what. So that's the pollution pathway. So based on all this, we have that these attributes could be selected based on which the criteria for selecting a landfill site can be determined. So this is the CPCB guidelines. So they have made 7 categories: accessibility related category, receptor related category, environmental related category, socio-economic, waste management related, climatologically related, and finally geologically related. Now let us look at the criteria. Some of them: accessibility related is type of road and distance from collection area. So these are 2 parameters, 2 attributes. Receptor related means the effect, who will be affected by pollution and all. Population within 500 meters, distance to nearest drinking water source, use of site by nearby residents, distance to nearby building, land use zoning, decrease in property value with respect to distance, public utility facility within 2 km, public accessibility. All these are factors which can be considered, and we can do relative comparisons between 2 sites to say which one is better, and accordingly we can give scores to it. So again, like public acceptability. So is there any compensation? So to make this site actually happen, then we may have to compensate the people. So that involves actual cost. Or decrease in property value, there is actual cost involved. So these detailed calculations are done later. What we are doing now is just a relative measure between the 2 sites, which one is more or less, right? So this kind of evaluation helps in the ranking of the sites. That's all. But for actual environmental impact, actual cost considerations, we have to do further detailed calculations. And as I told you, this cannot be done for all sites. It could be only done for few sites. That's why we do initial screening via this ranking procedure. Then we can do those particular calculations. Then coming to environment related, critical environment, distance to nearest surface water, depth to groundwater contamination, water quality, soil quality. Socio-economic, job opportunities, order, vision, waste management, life of site, that is possible based on area. If the area is less, the life of site would be lower. Precipitation under climatic features, then soil permeability, depth of bedrock. So these are the other parameters or other criteria, slope pattern, seismicity, that are also considered. The method they have CPCB have suggested is to create SSI, is to multiply weights with each of this sensitivity index of each attribute, and we get a total score, and total number of attributes is 32, and overall the summation of all the weights comes to around 1000. So that means some weights within this 32, some has got higher weights, some has got lower weights. So overall, when you add them up, the total weightage given is 1000. So this is the example, a case study from where 2 sites in Varanasi has been evaluated, As you can see that all these 32 attributes are being considered, and like type of road, the weightage is given is 25. This is as per CPCB guidelines. So when you add all these weightages for each of these 32, it comes to 1000. Now we can multiply this with the SIE, that is the sensitivity index of that site. So here the national highway is present, here the state highway is present. So obviously here the score is higher. So it is a national highway gives you more access, right? So that's why the score is lower, because lower score means lower impact. Then distance from collection point, this is 9 kilometers, this is 14 kilometers. So obviously this is lower impact, so this is 0.25 and this is 0.4. And in such a way, air quality conforming to industrial standards, conforming to residential standards. So this is 0.6 and this is 0.8. Job opportunity, because here maybe industries are only there, here there is only residences in the surrounding area. So we have to conform to residential standards which are more higher compared to industrial standards. So that's why the score is higher, right? Then so that's why the score is more hazard is there. Then order, this is high order, where this is moderate order. Accordingly the score over here is lower and this one is higher, and in such a way all these relative values are being given. And once this is done, then this has been added up, and the total score for site number 1 comes to 483, which is for Pado, and this 407.7, this is for Karsada. This is the score that has come. So obviously this score is higher. So environmental, based on this ranking, a few sites may be chosen for detailed environmental impact assessment. Over here only 2 sites are there. So maybe both could be even considered for environmental impact assessment, or we can choose the one which is better and we can consider doing an environmental impact assessment. So that means where scores are less, the value is more. So it's a better site. So obviously this site we will consider for further environmental impact assessment. This is a summary of these 2 sites. As you can see that this is rank 1 and this is rank 2, and here instead of the 32 categories, we have now combined them into accessibility, receptor. We have divided into those 7 categories, and these are the values for each one of them. For some site, for both of these sites, some value is high, where here the value is low, this is higher, whereas over here the value is actually higher and this one is lower, right? So for each aspect we are considering what is good or bad, and then based on multi-criteria we are evaluating which site is more suitable. So over here this site is chosen. So the final site selection, as we have discussed, is based on detailed environmental impact analysis, social acceptance, land availability, transportation cost, and the actual cost of creating that sanitary landfilling facility. And we have determined what sort of cost goes into that, right? So this is the final selection criteria. Maybe we will consider a couple of sites and then we can do detailed analysis to select a final site. Then of course, transportation cost is a big deal, and we have already discussed this is the average hauling distance from centroid of ULB is considered. Like for example, one important thing is, for example, in both the sites, or suppose I am comparing 3 or 4 sites, the liner, leachate system, daily cover, final cover, more or less the designs are same. It's not that different until unless there is a lot of change in the geology or in the soil type and so on, right? But otherwise these are more or less same. So what is different is the soil quantity required in each site may be different. Why? Because one area may have got this sandy soil, in the other area there is clay soil. In the area where there is clay soil, I don't have to import soil from other places. Where in an area which has got sandy soil, I have to import soil from other places. Soil is one of the most important determining criteria for selecting a location of a site or to determine the cost of a particular engineered landfill facility. So we have to be very, very careful about how much soil has to be imported, because it involves a lot of cost, right? And the quantity of soil required is pretty high for a landfill site. Sites with high water table hilly areas may be chosen, but in that case there has to be additional investment for the engineering designs or specific engineering designs that has to be adopted for this kind of site. This is another case study where you can see that this is an international case study from Washington State Department of Ecology. This is their guidelines actually, and you can see that here they have considered a more detailed number of criteria, and what they have considered, like under climate they have considered precipitation. This is more like an environmental impact, and different kinds of impact they have considered. So precipitation and wind they have considered, and they have determined the impact for precipitation. That means it will create more leachate, it will create more gas, it will affect the gas operations, it will create operational problems, because as we said that if there is a lot of rainfall, then we cannot use heavy equipment, then there is the site runoff that will be generated. And to handle all this, there is also mitigation measures. That means I have to invest more in a drainage and erosion control plan. For leachate, if it is generated more, then more amount of cover soil and more smaller phases has to be thought of. For gas production, if I want to control it, then gas control recovery system has to be installed, or we have to design a more sophisticated one. And similarly, operational problems and designs has to be taken care of, which also will require more investment. So this actually gives us an idea about how much investment would be required, and we can do this comparison for different sites and we can put some score for it, right? For wind, litter, order, dust, litter means spread of garbage all around in the surrounding area. So the operation plan needs to be modified if there is more windy area. Then order, daily cover has to be more thicker, so to prevent order to spread because of wind. Dust will also spread, so gas control has to be done because most of the gas contains a lot of dust which actually spread in the surrounding areas. So all this will require further mitigation measures and further investment, and actually that makes the site more costly, or the score of that site will obviously be lower. Topography, these are some of the characteristics: access, operation, aesthetics, capacity, water body. We will look into contamination of the surrounding water and all. Roads, the surrounding roads, there will be disruption because of continuous movement of waste vehicles. Then access, utility systems with the availability of water, availability of electricity. So this kind of things are there. So sites with more precipitation should be rated lower, obviously. If predominant wind flow of a site is towards settlement, then rating of that site is also low. So that is what we are evaluating, and we would give ratings as per that. Then adequate relief relief means the change in the height within the site. Adequate relief provide visual isolation and wind protection. So if it is a little bit lower and all, it is protected from wind. But it should not create problems for access, and because level areas are good for operating heavy equipment and so on. So if too much of relief, that will have some negative effects. So same thing can have a positive effect and a negative effect. Both has to be considered as well. Similarly, for soil types, geology, these are the criteria. Soil impacts are groundwater contamination, construction. Like for example, if thickness is not adequate, then groundwater will be contaminated. So we require a secondary bottom liner. The construction of that site will be affected. So excavation plan has to be changed. Operations on site, operation plan needs to be changed. Then the physical and chemical characteristics of the soil, like depending on that, the leachate movement would be different, the leachate attenuation would be different, operational usage will be different. So actually, for leachate, to prevent leachate movement, we have to import for the soil, maybe leachate attenuation or spread of leachate we have to do, add cement into the soil, so soil amendments have to be mixed, and so on, right? So similarly, geology, considering this bedrock and what kind of environmental hazards are there, all these things also needs to be considered. So bottom liners and final cover require silt and clay types of soil, while gas venting and backfill for leachate collection system requires sand and gravel type of soil. So both type of soils are required. It's not like we will just require silt or clay soil, but for determining the drainage collection layer or the gas collection layer, we require also sandy and gravel type of soil. So we have to find out that what sort of soil is available in the site and what is not, and accordingly we have to take a decision. Soil for road construction and topsoil, and sites, we also require soils for this, and usually sites with silt and clay soils are rated high, and sand and gravel soils require extensive engineering to be used as liner. So we have to do a lot of mixing of other material and so on. So otherwise, if nothing is possible, then soil has to be imported, which is also much higher cost. So based on this, we can give ratings to different sites. Similarly, other parameters are biological environment, what sort of habitats, unique species, migration routes of some animals, flow systems are migration routes are there. For hydrology, we have to consider the flow system of the groundwater aquifer, the spread of the aquifer, the aquitard. Then for land use, on-site properties which are there, what are the adjacent properties, number of property owners, existing zoning, comprehensive plan for that area. All these things that are there, and each one of them will impact different aspects. Aquifer, if the contamination spreads, it will affect public health. So we have to also consider mitigation measures for all this, right? So these are some of the mitigation measures listed. For habitat, we have to do certain replacement of that habitat. Migration routes, we have to create certain buffer zones. For aquifer, alternative water sources has to be found for that habitation, because you cannot draw water from that aquifer because of contamination. So for flows, for controlling groundwater contamination, the leachate management system has to be designed or augmented, right? So this determines the cost of operation for that particular site, as well as that will result in a lower or a higher rating for that site. So hydrogeology is very important, which is occurrence, distribution and movement of water below the surface and its interrelationship with geology like rock features, soil features and so on. So this is very important for landfill site design. And groundwater flow system determines where leachate will flow and which aquifers will be affected. So these two things are very important that needs to be investigated in detail for each landfill sites. And so preference would be sites which have a local groundwater flow system, that means it doesn't spread too far away. The hydraulic gradient of that particular soil is low, of that area is low, and hydraulic conductivity of that soil is actually low. So when these features are lower, then we can give it a better score, right? And always for land use and all, this acceptance, NIMBY, that is not in my backyard, this kind of protest always happens. So we have to give adequate compensation, we have to build consensus. So that will also require different amounts of effort in different areas. Accordingly, we can give some rating to those particular areas. Shallow water tables are less desirable compared to deep water tables, because if it is shallow, then there is more chance of contamination. So these are some of the things that we should consider when we give ranks for selection of sites. So for this particular case study, you can see these are the criteria which considers the human environment, the physical environment, some general requirements, and also the economic consideration. So all the criteria, that is considering the cost of operation, the transportation cost, then the cost of land, all these things are considered within the same analysis framework. And this is the weightage given for each of these criteria, which could be generated via some ratings given by experts, or doing a AHP based on experts' opinion. And for each of these criteria, we can create this kind of a scoring pattern, where in this particular case study, they have used a score of 1 to 10, and this is again a relative score between the sites. As you can see that and they have created this criteria, like this is for soil. When greater than 50 feet of fine grained unconsolidated material, the rating is 10. Whereas less than 10 feet of non-reapable bedrock, the rating is lowest, which is 1. So that means this is depth of the bed of what kind of soil is there. So 10 to 50 feet of coarse grained unconsolidated material, then the rating is 4. So this is coarse grained material, so that means it allows passing of this will allow passing of leachate below. So based on the soil type that is available, we can give some score for different kinds of soil characteristics in that particular landfill site. We multiply this score with that this soil, and then we get a value for this particular criteria. Now, once we add up all this for all criteria, we get an overall score for this site and we can do it for multiple sites and see which one is the best. Same as we have done with the CPCB in the study of Varanasi. So obviously all these steps require us to collect a lot of data, even though we can do all the analysis all together, or we can do it in stages as given in CPHEO guidelines, but all this will require a lots and lots of data. So for example, you will require topographic maps, you will require soil maps, you will require land use plans, water use plans, and these are some of the sources from where you can obtain this kind of maps. Then floodplain maps, geology maps, aerial photographs, and this is what they are used for. So this table is taken from CPHEO guidelines, and this basically we have discussed. Soil maps are meant we have to find out that what sort of agricultural use was there or is there, and this will help us to determine what is the loss or productive loss in future years, indicates the type of soil near the surface. All these things, information is gathered from here. Then similarly, if I get the floodplain maps, we can use it to delineate areas which are within 100 years of floodplain, and that means within these areas we cannot have any kind of landfill site. Same goes for geologic maps and other kinds of maps. So these are other data, seismic data, road maps, windrows maps, rainfall data, groundwater maps, and so on. Windrow maps indicate predominant wind direction in the area based on which location and orientation of the landfill footprint has to be determined. So if I have our habitation over there and I have got the landfill site over here, the predominant wind pattern, of course predominant wind pattern is considered because wind flows in every direction all throughout the year, but the main predominant wind direction may be like this. So that means lot of dust will go into this habitation. So I will not select this particular site. But if a site is located over here, the predominant wind direction is like this, it will not affect that particular area. So I can choose that. So this windrows map actually help us to determine this. And we will get the data from the Indian Meteorological Department, and for different areas they have this windrows maps. Similarly, rainfall data is required to determine what sort of infiltration, what sort of rainfall will happen in that site, and that from there we can do infiltration analysis, we can do a total water balance analysis of that site, and then again this data is available from IMD. And so on, we can collect other data. Now, all data is not available, so in that case we have to do some site investigation ourselves. Maybe we have to do a subsoil investigation if the data is not there. So, or we have to do a groundwater or hydrological investigation, surface water investigation, topographical investigation, environmental investigation, and traffic investigation. So, if data or maps are readily available, we can go and check it at a potential site, but if these are not available, then we have to do the investigation ourselves. Now, subsoil investigation requires physical, hydraulic and chemical properties of the surface material and the bedrock for that particular area. We need to analyze those. Structural integrity of the subgrade, so that we can say if it would be able to take care of that additional weight coming from landfill or there would be subsidence. Availability of soil for liners. So these are the things that we need to investigate or do check with different methods and test methods. Groundwater hydrological investigation incorporates soil or bedrock condition, groundwater depth and pressure mapping, baseline groundwater quality, groundwater flow direction. So we need to create contour maps for groundwater based on the piezometric surface. So all these things could be taken up if I measure the groundwater height at the different wells which are located over there, or we can take some measures using some equipment also for that particular area and determine what is the groundwater table for that particular area, and also the direction of flow and so on. Similarly, surface water investigation is done. We need to look at the detailed drainage plan, the water balance analysis for the site, and the water quality analysis for the site, and so on. So this is the kind of data that has to be collected and the detailed site investigations that has to be done. So these are some of the references that you can study. And to conclude, selection of site of landfills is challenging, particularly for densely populated areas. and proposed site requires final clearance from multiple agencies, and a reuse of existing sites with suitable modifications and expansion remains the only available option in many cases, because land is very, in our country there is not too much land available, because there is a lot of settlement, the population density is high. So key is reduction of waste going to landfill. So we should reduce as much of waste that should go into the landfill. Thank you.